Welcome back. Let's do another node voltage problem, because you can never have too many node voltage problems. It's just good practice. Okay, so we're given this circuit here. It's a pretty short problem. It's just practice. Practice makes perfect. That's just, something they pay me to say. It's like the union. I think it's in the union contract. I have to say that. Anyway, we got a 1 amp current device. Could be a load, could be a source. I have a 6 amp current device. Could be a load, could be a source. At least one of these has to be a source, or you've invented a solution to the energy problem in the world, and you'll be a bazillionaire. So, okay, here there's no device, so this is really V2. And we're going to put V1 at the bottom. So V1 will always be at the bottom, and at the top you're basically putting a node on the other side of every device, basically. Okay, let's throw some. So we're asked to find. What are we asked to find? We're just asked to find V1 and V2. Just a node voltage problem. That's what node voltage spits out, is these voltages at these test points, or nodes you could call them. And once again, the value of this, or one of the ways to think about node voltage is, if you were doing testing on a circuit, you'd take a voltmeter and you'd hook the negative terminal to this ground node, and then you'd poke around with a probe and you'd be measuring these voltages. So that's kind of the way that I think of it, just as a practical, to relate it to something practical. So here's an 8 ohm, here's a 40 ohm resistor, here's a 80 ohm resistor, here's a 120 ohm. Okay, so let's throw some more currents on here. Well, this 6 amp, let's just agree with him, this is 6. Then let's say this current splits this way and this way, which is what it's going to do, right? And then when it gets to this point, let's say more of it goes down that way because it wants to go home. And this is all one node, so this whatever's coming in here is going to come out here. Well, let's agree with this 1 amp, throw that on there, and then let's throw that on there like that. This one here is the most guessy one, right? I mean, you might want to guess that this current is going up instead of down. You might. But keep in mind, what we're doing, we're guessing. Now you try and guess correctly. And if you guessed correctly, your answer will be positive. So if you get a negative answer, it just means that you guessed incorrectly. And if you have too many negatives piling up in the end, and it's confusing you and messing up your algebra, just start over and flip the guess around. Okay, you can do that. You can rewind your problem back to the beginning and flip your guesses around. Okay, but we're guessing these current directions, and we happen to be guessing correctly. And like I say, these ones are pretty clear that that's what's going to happen, just intuitively a little bit and with some practice. But over here, this one is a little bit more guessy. Anyway, so let's write some node voltage equations. So in is going to be negative and out is going to be positive. So node V1. So here I've got in 6 volts, so -6, and then this current coming out right here it's V1 here on one side and 0 on the other. So by Ohm's law, that's going to be V1 over 40, and it's coming out, so it's positive. All right. This guy here, this current is going to the right. The potential must be bigger on this side, on the left, in order for that to happen. So the expression is going to be V1 minus V2. V1 on the left, because it's got to be bigger to push the current to the right. Right? And V1 minus V2 over 40, that's the Ohm's law thing, and it's coming out, so the whole term is positive. And that's, 8. Okay, and that's the 3 currents coming in and out of this thing. Okay, and those things sum to 0. That's that, and we can do that again. So do that at node 2. So once again, this is all one big node. If it helps you, just draw it as a big old node if you want. Okay, we've got guys coming in, this one, we've got these two guys coming out and another guy coming out. So it's so we've got this guy coming in, so it's going to be negative. And what is this guy right here? It's the same term, so it's v1 minus v2 over 8. And don't forget the negative applies to the whole thing. Put some parens on there if you need to keep that straight algebraically. And then I've got this guy coming out of v2, right? I've got this current coming out of v2, so it's out is positive, and it's going to be v2 over 80. And then I've got this guy coming out of v2, so it's positive, and we know that current is just 1. And then we've got this guy coming out of v2, and by Ohm's law, it's going to be v2 over 120. And it's the term is positive, it's coming out. Did I get them all? I got this guy coming in, negative. I've got this guy coming out, positive. I've got this guy coming out, positive. I've got this guy coming out, positive. v2 over 120, v2 over 80. You know, check your work like that, and those guys sum to 0. Okay, there's two equations and two unknowns. Let's write that. There's two EQs, two unknowns. You know, therefore, a solution exists. That's how you know you can stop writing equations and do and just do an algebraic solution, or whip out your calculator. Because when you have the same number of equations, the same number of unknowns, you've got a solution, and you can stop writing these equations. Okay, and so all we need to do is put this into a form that's solvable, and I'm gonna put in standard form. So factoring on this first guy, so this is NV1 in standard form. Factor out the V1 and you end up with 1 over 40 and 1 over 8, right? The 40 and the 8. And then factor out the V2 and you end up with a minus 1/8. And those equals, and then move the 6 to this side, those equal 6. This is standard form, what we call standard form. And then the NV2 in standard form is going to be factor out the V1. So you want these positive variables, V1, positive V2, and then some coefficients, and then the number. I'm not sure I'm calling these the right thing, but these numbers and then these numbers over here. So the minus 1/8. I could go ask a math teacher, but I'm not a math teacher. So V1, pull that out, you got minus 1/8. Pull the V2 out, you're going to have an 8th, an 80th, and a 120. Okay, you might be able to enter this into your calculator, or you could go one more step and combine the constants, right? And so at this point, it's calculator solution. You write that on your homework, so I know, when you just pulled out the machines. So V1 is 120 volts and V2 is 96 volts. That's the answer that your calculator is going to give you this answer. Okay, that's the method. This is a very mechanical kind of process. There are similar mechanical processes to this that are a little more elaborate, and those have been automated. And that's what's in the programs that solve these problems in real life. In real life, it's worth talking about that a little bit. In real life, this circuit is so simple. Have you ever take your computer apart? Look at a microchip. It dwarfs this. There's no way that you can solve this on paper with my megapixel pen, on my whatever. You can't. You have to use software. But so that's what's done in real life is software. But that's not what we're trying to do in this class. In this class, we're trying to just conceptually understand what's happening here. And if you understand conceptually what's happening with current and voltage and resistance and all that, it just helps you understand not only what's happening in the physics of it, but it's also important to kind of understand the methodology, because some of you might go off and write software that works on that, and it's a good skill to learn how to think about problems algorithmically, right? That's what I'm talking about. Okay, so there's two parts here. There's the physics and the getting an intuitive understanding of how circuits work. There's that, and then there's the algorithmic thinking part of this, right? Where you think about a problem step by step by step. And the reason that's such a super valuable skill nowadays is because everything is automated nowadays. So if you can learn how to think things through very linearly, very step by step, very algorithmically, you can code it, or you can talk to a coder that will go code it, and then they'll fire you because they don't need you anymore. They'll hire a computer. Just kidding. All right. Hope this was useful to you. See you next time. Bye-bye.